Hello, everyone. We are live with a new CODAS event. We have today Sean from IXO, Miguel from SimplyVC, and Mac from Block Science. And they will help us today in working on an automated market maker. And for that, they will be using the Cosmos-SDK Bonds module. Hello, everyone. Thank you for coming. Hope everyone will enjoy the workshop. If there are any questions from Block Science, and they will help us today in working on an automated market maker. And for that, they will be using the Cosmos-SDK Bonds module. Hello, everyone. Thank you for coming. Hope everyone will enjoy the workshop. If there are any Okay, I was having a double there. No worries. Thank you everyone for coming, and we can get started. Thank you so much.
Great. Thanks for joining us today. And we're very pleased to bring to you the work that we've been doing on the bonds module, but also to contextualize this within kind of why do we need these automated market makers. And we have a particular view on this from an IXO perspective, where we're building an Internet of Impact, so the ability to sense and respond to changes in the state of the world, and to programmatically apply capital to where it's needed, and in response to where it succeeds, and cybernetically finance what works in terms of sustainability. And so the origin of this work was really the idea to create a universal bonding curves module, and that we've been working on for the past year, and then that has been applied within the context of IXO as an alpha bond. So an alpha bond, we'll get into more details about this, but it's an automated market maker which has been specifically purposed towards sustainable finance. And so I'd welcome you to have a look at the Alpha Bond website, which is alphabond.org, where we give an overview of kind of the use cases, how it works. We provide some links to developer resources. And really, I hope what you will see from this is the diversity of applications that can be built using bonds functions. And so what we're going to see today, firstly, is how to go about configuring a bond and creating a bond. And then we'll see this particularly in relation to a specific use case. So we'll draw out kind of a health use case and show how that is parameterized and how it can then play out. And so we have some simulations based on the work which Block Science has done, and Matt will present that in the last part of the presentation. And so with that, I'm going to hand over to Miguel, who's going to really take us through the details of the workshop, and then we'll return to hear from Matt towards the end.
Thank you, John. I will start sharing my screen. In the meantime, hi, I'm Miguel. I work at SimplyVC as a software developer, or more fancily, blockchain mechanic. Yeah, during the past year, I've been working with Sean on sort of leading development of the bonds module. Yeah, and it's been a very exciting journey, and I hope you get to appreciate our work during this presentation. So anything that I will be using, or any commands that I will be submitting to my terminal, you can find on this repository on GitHub. So it's actually like, this is the full link, github.com/exoworld/bonds, on the Code With Us branch. Yeah, there's, if you go on the Code With Us folder, then you'll find a README, which is what I am looking at, actually. Yeah, so there's a sort of a small agenda of what we'll be going through. We'll create 3 types of bonding curves, and then we'll move on to the more fun and interesting alpha bonds. yeah, so I think we can actually start. So the first thing that if anyone's following on their system, the first thing that you should do is actually clone the repository, and switch. So git checkout the code with us branch. So if I go git status, we have the code with us branch that we're checked out already. So this is just two terminals showing the same thing, really. And yeah, so let's just jump into the first demo, where we'll create a simple bonding curve for algorithmic pricing. So yeah, just a bit of context, I guess, to all of this. The bonds module supports various types of bonding curves, not just basic ones like power function. It has power function, sigmoid. It has also an atomic swap, sort of a Uniswap-like AMM, XY equals K model, and also augmented bonding curves, which is actually something developed by block science. Yeah, so our first demo will sort of show the power function specifically, and it will actually reveal some interesting features of the bonds module in the process. So this is the file that I'm sort of getting my commands from. On the right, I'll just start the blockchain with some preset data, which will have some accounts created, Alice and Bob, and so on. And they'll all have some balance for us to sort of have conveniently. And I'll just leave that running in the background. So I have a new tab. Yeah, so first thing that we'll do is just sort of have some sort of three convenient variables. All of them will have the address in them, so we can refer to them easily. Then we can jump to the bond creation. So it's a very large command, so I won't type it out manually. I'll just copy paste it. But I guess what's interesting to go through is all of these parameters, arguments that we're passing. So we're creating a bond here. We're getting a bond of the bond token will be my token. It's a very original name. Then we have sort of a human readable name. I guess even my token is human readable, but we can go a bit more crazy here, I guess, and a longer description. Then we have the function type, which in this case we've picked the power function. It's sort of the more simple one, or like the typical one that you would see in a bonding curves article. And we've picked out actually these specific constants for the power function. To give you guys a sort of a visual representation of this, what it actually looks like, because here we're just seeing M is set to 12, N is set to 2. I actually have this graph set up here. This is the actual graph that we're setting up. So we have the M, the N, and C. We have X is actually the supply. So at the bottom, the supply of our my token. And on the y-axis, we have the price, P. So we will actually use this as sort of a cross-reference as we're submitting our commands to make sure that the calculations are being done correctly. So as for the reserve token that we're using for this bond, Atom so that's what we'll be paying to buy my token from the my token curve. I can actually skip some of these arguments. We'll use some of them later on, or most of them actually. So I'll just stick to the important parts, which is actually the first number of arguments. But actually down here we have batch blocks set to 3. So what is this batch blocks? So So an interesting feature of the bonds module is that it has order batching. So whenever Alice buys or Bob or whatever, the buy doesn't happen immediately. Rather, it goes to a batch of orders, which in this case is 3 blocks. Sort of the span of it is 3 blocks. So whichever sort of any order that comes in during that 3 blocks will get included in this single batch, and the buying power and selling power will get averaged out. So if Alice and Bob both buy after each other, so if Alice comes first, she won't get as much of a better price for buying first, because the prices will get averaged out. So that this is actually essentially a front-running prevention mechanism. So we don't have sort of people trying to buy before each other or sell and making a quick buck. Yeah, so the bond owner in this case will be Alice. Yeah, we can just go ahead and create our bond, which will get a confirmation that it's created. Yeah, and these are all of the arguments that we supplied here, actually. We have some convenient commands to be able to query the bond. So right here, we're using bond CLI query bonds in the module, and we're querying the specific bond called my token. And yeah, everything's there. So rather than just talking about this fancy batching mechanism, I'll actually leave sort of we'll keep an eye on the current batch for my token. So every bonding curve has a single batch, so we can actually just focus on the batch of my token, the batch of orders. So if I go ahead and yeah, so we can now actually query. So now that the bond was created, the buying can start basically. So we can actually query the price that would be charged if, for example, 10 my tokens are purchased, and the price is actually in this case 5,000 microatom, which if we go back to the visual representation to confirm this, actually find out that 10 tokens is 5,000. So you probably noticed that I used the second red curve, not the black curve. So as I sort of pointed out earlier, this curve is actually the supply, and so we have the supply on the x-axis and the price on the y. The red curve is the integral, the mathematical integral of the first curve, which actually gives us the reserve that is required to reach a certain supply. So if we want to reach a supply of 10 tokens, so we're minting 10 tokens as we buy, the price to do that will be 5,000, which is actually the area under the curve, interestingly. So yeah, let's go ahead and buy from Alice. We'll buy 10 my token with a max price or spend of 1, 2, 3, 4, 5, 1 atom, I guess. Yeah, so actually, if we look here, it doesn't show all of it, but yeah, for a number of seconds, there was our order that went in, and after 3 blocks or however there was remaining, it got processed, and if we query Alice's balance, actually now see that she has 10 my token and she has 5,000 less microatom. So the purchase was successful. So So now if we query again the buying price of 10 my token, it will be different, because now on the curve we have actually moved sort of this is our new starting point. The supply is 10. So now if we want to buy 10 more tokens, we have to get all the way up here to 20. There it is, 20 supply. But you might notice that our 34,000 on the left side doesn't match the 29,000 on the right side. That's just because we're actually paying for this range of area under the curve, rather than like all of this. So the green part was already paid by Alice, and now we're going to pay the blue part under the red curve from Bob. So let's just go ahead and do that. We can actually keep an eye on the batch above. Again, we'll see the order coming in. It's all of this is there. And after a few seconds, once this reaches 0, it will loop back and our buy order will have gone through. And if we query Bob's balance, yeah, he has 10 my token, and that's the amount charged, subtracted from his balance. So similarly, so this is how much the blue part is how much Bob paid. So if Alice were to sell right now, she gets all of this in return, rather than just what she paid. So we're going to sell from Alice, sell the my token to make a bit of a profit. If we query Alice's account, so you can see that the sell order went through from here. It's no longer in the batch, and we can query Alice's account. And so the original amount of microatom was like this amount, and now she has 24,000 extra. Fortunately, Bob, if he sells, which we'll do right now, he'll get what Alice paid originally, right? So we query his account after selling. The my token are gone; they get burned, and he didn't get all of his original atom in return. So yeah, this sort of incentivizes, I guess, early buyers and holders as well, assuming that the price will keep going up. Yeah, that was the first demo. I hope it wasn't too fast. If there's any questions, please let me know. But yeah, we can move on to the next one, where we'll cover more of these arguments to the bonds module. Yep. So our second, if I go back to the README, our second demo will be to create a Uniswap-like market maker. So essentially a token swap. What I will do in this case is just stop the batching. It's no longer super interesting for us. I'll just expand this terminal, and actually I'll just restart the blockchain. So I'll Control-C, and just so we have a fresh slate of balances, so that if we query any balance, we'll have it will be more clear what happened, I guess. Yeah, so our goal in this second demo will be to create a pool of Atom and BTC. So again, we'll copy our addresses for convenience. And yeah, what's different now is that obviously the token name will be different. We've named it Atom BTC Pool. We gave it a nice name. The swapper function is what we'll be using now. The function type. It's what sort of how the bonds module recognizes the Uniswap-like function. And in this case, we will have 2 reserve tokens, Atom and BTC. So in total, there will be 3 tokens involved. This is above the bond token, the token that will get minted, the token that we're creating. And below we have the tokens that, so obviously we're assuming that BTC was somehow bridged to this network, and Alice and Bob already have some BTC, in their balance. Just take my word for it. I think we saw it earlier, anyways. Yeah. So what else is different in this case? We're setting a transaction and exit fee. So transaction fee will be applied whenever there's a buy, sell, or anything else really interacting with the bonding curve, whereas the exit fee is an extra penalty. So it's not just the exit fee that will be charged, but the exit fee and the transaction fee, sort of an extra penalty for leaving the bonding curve. So for selling, so it sort of disincentivizes, I guess, selling. So yeah, we have the fee, and actually the fee address is now relevant. The fee address is where the fees go. So any charged fees on buys, sells, whatever, will go to the fee address, which the creator is actually able to specify whatever they want. So they could actually specify their own address as the fee address. We've picked a max supply of 1 million, I guess. Yes. Atom BTC pool tokens. It's, for no particular reason. It's just a sort of a limit. We have an order quantity limit, so this sort of does not allow a single buy to be greater than certain amounts, just to prevent mainly like large amounts of tokens flowing into the bonding curves and causing some people to be unhappy, basically. So in the case of the swapper function, we also have sanity rates. So here we are saying that we expect the exchange rate between Atom and BTC to be 3,000. So 1 BTC will be 3,000 Atom, which is approximately actually the real sort of exchange rate. But we don't necessarily want that specific exchange rate, so we sort of allow a 10% greater or less. So it will be 2,700 to 3,300 actually. And yeah. And yeah, just as last note, we're setting the batch blocks to 1, so we won't have to wait for orders to be processed. They'll be processed immediately. So yeah, let's just create the bond. Boop. From Alice again. She will be the bond creator. And yeah, that was successful. So we can, can query it actually just to make sure, double check, and all of our inputs are here. Yeah, so let's go ahead and buy. So buying in the scope of sort of a Uniswap-like mechanism, buying will be actually adding liquidity to the pool. So if Alice buys Atom BTC pool tokens, she will actually be sort of supplying liquidity for oops, I cannot go scroll to the left.
Miguel, can we take like a small break and maybe answer some of the questions from the community? Yeah. We have a lot of questions here
already.
So maybe just go here in the right, pick the ones that you think we could answer, and just show them on the screen.
Sure.
Should I pick them or do you want to pick them?
I think I can just go through them, I guess. So you can see them, right, on my screen?
Yeah, cool. CoinGlow.
Yeah, so just this one that I saw immediately is the Desmos page links are on the scripts actually. So I forgot to mention they're on. So demo 1 power will have the desmos script. So anyone can just go ahead and access that link and play around with the curve and change things around.
Maybe just add it here as a comment to the chat.
Yes, that's a good. Yes, definitely.
Take it from there and just pass it here for people to have it.
Oops, I don't think I. Where's the text?
No, just post it here in the comments at the end.
Yeah, the text box. I don't see it though. Where do I write?
In the chat at the end. Don't you have?
No, I don't have a box to write. So I don't think I don't think I can post.
Post it in the private chat, and I will post it into the YouTube comment.
Okay. Yeah, actually, in the private chat I can, right? So, okay, that's awesome. So I'll actually post the second one as well, since we'll open it up. So this is for the demo 2. Okay. Yeah. So that should be very fun, actually, to just mess around with.
Okay. Let's pick some more questions.
Yeah. So has the bonds module been audited? Not yet. It's so it's not production ready. It's very experimental in some sense. But I think the main goal that it has achieved is just to be an inspiration in general and sort of prove that all of this is possible on Cosmos. It's very interesting. Yeah. So. Whoop. Batch price. So yeah, we can take this question. Is the batch price adjusted for the different volumes per order? Yes, definitely. So if Alice wants to buy 2 tokens and Bob wants to buy 1 token, the prices will get averaged out. But obviously, it will take into consideration that Alice wanted to buy double the tokens that Bob did. So she will have to pay double what Bob pays, but yeah, the sort of they'll each get charged a proportional amount of the total price, proportional to the amount of tokens they want to buy. Can there be separate curves for buy and sell to create a built-in bid-ask spread? So actually, if we use the transaction fees and exit fees properly, we'll actually be sort of having 2 curves. So if we set an exit fee percentage, for example, the selling curve will effectively be sort of shifted a bit down. The seller will get less tokens in return. So I think, yeah, that's sort of the only way currently to have two separate curves implicitly. So is this approach still vulnerable to front running? Most probably. So it's the batching is not front running proof. It's more of a deterrent maybe, or as a first line of defense against front running. But I mean, between one batch and another, sort of if front running can take place sort of between batches, right? If the orders come in the same batch, they will get averaged. That's fine. But if the attacker waits, especially if there's a small batch size, the front running is still possible. And there's, I mean, a multitude of other ways to front run. People are very creative. Can the bonds module be used on a Cosmos chain? So I mean, bonds module is in Golang, so there's that problem, obviously. But I mean, it can probably be used. I wouldn't see. I mean, it would be included in the same chain that the WASM module is. So it should be. I mean, we haven't tried this out, but and I personally I really want to look into Cosmos-WASM a bit more. But to figure out what's possible, really. Is the bonds module used when creating a new blockchain, or is this for creating Cosmos-WASM contracts? So, I mean, I'm not sure what the question is saying exactly. So if I understand correctly, the bonds module would get included as like a module similar to the bank module in Cosmos SDK, like any typical module. It's not a Cosmos-WASM contract. Does this mean we can easily build Uniswap on Cosmos? Yeah, I mean, so the nice thing about Uniswap is that the formula, the equation, the constant product model is very, very simple. I mean, it's not complicated like to implement. So yeah, I mean, and there's other people that have implemented it as well. Actually, not. I mean, it's an obvious thing to implement, I think, in a blockchain. Yeah. So, hello, Lev. Yeah, I think that's all questions. So maybe we can proceed. I think I'll have a small drink. Yeah, so I think we can proceed. So actually, if you can post them also the second Desmos link, which I've posted on the private chat, that would be fantastic, because we'll get to it very shortly. Yeah, so let's proceed. Okay, so we've created our bond. We have two. Yeah, let's look on the side. Again, we have two reserve tokens and one bond token. That's always the case. And yeah, let's get to buying. So what I was saying earlier is buying in the scope of like a Uniswap mechanism. It would actually be like adding liquidity to the swap. So in preparation for then people to come and swap their tokens from Atom or BTC to Atom. So if someone needs to provide that liquidity. So the buy message in the case of the swapper will actually be to add liquidity. So we'll actually go and do that here. Boop. Successful. Yeah. And this is the first sort of amount that we will have in our reserve. We have 3,000 Atom and 1 BTC. Both of those were subtracted from Alice's balance, of course, and Alice now has 10 tokens representing her share of the pool. So that's actually transferable, her share, which is very cool, obviously. So she can, I mean, sell it, for example, for the same price that it's worth in the pool. Yeah. Now, if we go to Bob, he can buy as well. And an interesting point is that Alice, when she bought the 10 tokens, she was first of all she was buying with the sanity rate in mind, right? So we have clearly 3,000 Atom and 1 BTC. So if she tried to buy much more Atom and much less BTC, the sanity rate would have gotten violated, and the buy wouldn't have been allowed. So that's sort of happening in the background. Yeah, and secondly, Alice is also setting the price of the Atom BTC pool token, since she's buying, since she's the first buyer. Sort of she's saying that 10 Atom BTC pool tokens are actually worth 3,000 Atom and 1 BTC. So when the second buyer, Bob, comes to buy, he will have to respect this price decision that Alice made as the first buyer. So if Bob wants to send 300,000 Atom and 100 BTC to the pool, since that amount is sort of 10 times, not 100 times. I think that's so this is actually 1,000 Atom BTC pool. Since that's 100 times what Alice bought, he will have to pay 100 times as well the reserve that Alice paid. So I didn't make a mistake here. I intentionally ignored the ones here. Those are actually so we're specifying the max prices here. So if since there is a fee that will get charged, we have to specify a bit more our maximum spend, right? So that what the swapper requires plus the fee will get covered by this 31 billion or whatever, 456. Yeah, that's a large number. 310,000 Atom. It will get covered by that, and the 110 BTC, of course. So Bob has now supplied the liquidity to the AMM, and he has in return gotten the 1,000 Atom BTC pool tokens. Yeah. So I mean, now it's interesting actually to look at the desmos curve, right? In this case, in the case of a Uniswap, it's a bit different. On the x-axis and the y-axis, we have actually the balance of one of the tokens and the balance of the other token. So in this case, it's the balance of Atom and the balance of BTC on our y-axis. And the green line, I've set it to sort of the ideal exchange rate, right? So if the value of K, which is the product of the two balances, so say we have 3,000 Atom and 1 BTC, the product will be 3,000. 3,000 times 1, 3,000. So K will be 3,000. XY equals K. The optimal balance in our pool will be 3,000 Atom and 1 BTC. So if we obey the ideal exchange rate, right? Of course, once people start swapping, so if someone comes in and puts in Atom to get BTC in return, what will happen is we'll be traveling along this curve away from the optimal exchange rate. I mean, and then you'll have arbitrageurs come in and take advantage of that, obviously, and bring the price back to the ideal exchange rate. So what happens then if once Bob has bought, once Bob has supplied liquidity to the bond, what will happen is that the curve will sort of move outwards. So that's the purple curve. I don't have the exact values here of like Bob, but yeah, here we can see sort of we're still have the optimal exchange rate, like 12,000 division by 4 will be 3,000, so 3,000 to 1 ratio. between Atom and BTC. So our ideal balance will be 12,000 Atom and 4 BTC. Of course, once we have swaps, we will move along this curve. But what will happen now that there is more liquidity will be that the price slippage is less. So let's just go ahead and swap some tokens, and I'll explain that a bit later on. Yeah. So before we do the actual swapping, we can actually query the swap return from our bond. So if someone wants to swap 3,000 Atom for BTC, they can query the swap return. So we can sort of recall that our ideal exchange rate was 3,000, right? So we expect that for 3,000 Atom, for 3,000 Atom, we will get 1 BTC. Of course, there's some fees that get charged on the Atom that we're swapping, and we don't receive an entire 1 BTC. We get a bit less. So 1 BTC would be 1 million micro BTC. And clearly we have a bit less because the fee got taken from the amount that we're swapping. Similarly, if we want to swap 1 BTC to Atom, so if we work through the query, what we're actually querying, so we don't rush that much. We're querying from the bonds module. We're querying the swap return. We're pointing to our bond token. So the bond is identified by its bond token. And we're saying, we're asking how much do I get if I give BTC? How much Atom do I get? And the answer, again, so we expected 3,000 Atom, but some fees were taken from the BTC, and we got a bit less in return. So yeah, we can actually go ahead and do the actual swaps rather than dreaming about our BTC. We can actually get it. And yeah, if we query Alice's balance, so this will be a bit confusing because Alice already sort of gave some liquidity to the bond herself, so she already had some Atom and BTC missing. But what happened here when we swapped is that some more BTC got taken out of the balance and exchanged for Atom. I mean, some Atom got taken out and exchanged for BTC. So Bob can now, if he wants, swap 1 BTC to Atom, and we can query his balance first, just to make sure that the action is actually happening, what we expect to happen. So he's going to swap 1 BTC. So currently he has, let's say 8995. That's our reference point, and he's swapping 1 BTC to Atom. Can go ahead and query his balance, 8985. So we have 1 less here, which is 1, 2, 3, 4, 5, 6. It's actually 1 BTC. So what he specified is the actual amount that is taken from his account, but he gets a bit less Atom than what's ideal, I guess, because of charged fees. Here we can see actually some sort of checks and balances that the bonds module is doing in the background. So earlier we set some order limits, and now we're going to try to test the bonds module whether or not it allows us to exceed those limits. So we're using an amount which is greater than the BTC amount set in the limit. And I think did I pick a wrong command? Yes, I did. I think so. Wait, where was it? All right. Yeah. This is actually it. Okay. So if we paste that command, yeah, order quantity limits exceeded. We were not allowed to swap that amount of tokens. So here, if we try to, this is another check that the bonds module is doing for the swapper function. It's checking that the sanity rates are being obeyed sort of throughout the lifetime of the bond. And so the order will go through, but if we check on the blockchain side, sort of our node will have some extra logging for us, and it will sort of point out that the swap order was cancelled. So the reason why we don't see the error immediately is that the check sort of happens later on during the process, right? So the order quantity limit is something which is obvious to the module, sort of it can immediately check that for us, but to check the sanity rates, it has to do some further calculations before deciding whether or not our order is valid. Yeah, I mean, so at any point, Alice and Bob can choose to sell their tokens, and they will get an amount proportional to their bond tokens in return from the pool. So they will be removing liquidity effectively if they sell. Right, and that concludes our second demo. I will take a small break to regain my voice, but I will look at some questions if there's some questions. Okay, so yeah, let's pick. I have two questions here. In the bonds GitHub repo, there is a directory named X at the repo root. What does X mean? So that's a standard Cosmos-SDK thing, right? Like if you go on the Cosmos-SDK, the official Cosmos-SDK, you'll see the same X folder. It will contain all modules that the blockchain that I guess that specific repository is sort of defining, I guess. So in our case, if you go to the X directory of the bonds module, you will see just the bonds module. But where are the other modules? So implicitly in one of the files, like I believe the app.go, it's actually importing the rest of the modules, like the standard Cosmos-SDK modules. Yeah, it's just importing them. We don't have to copy all of these modules into our repository, right? That's the nice thing about Cosmos. We can just plug in the standard Cosmos modules and add our own bonds module, which will add functionality. So actually, if on the CLI I go like bond CLI transactions, I have like not just the bonds module. There's like a variety of other modules. All of these are coming from Cosmos-SDK. Similarly, for querying, I have all of these modules that I can query from. Obviously, we're focusing on the bonds module in this workshop. Hi, Angelo. And the second question, are you planning on launching a chain with this bonds functionality? So it's interesting that you asked that. We actually do have like a IXO actually, or not us, not SimpliVC, but IXO. They have a blockchain, which I personally have been helping out with as well. It's currently running the bonds module actually. So that's where you would find it being used. Yeah, and there's obviously more to come. So we're running the current bonds module, and there's other features to be added. Yeah. Okay. This is fun. So yeah, actually, so this is our third demo, an augmented bonding curve, which is sort of the more advanced, more recent addition to the bonds module. Yeah, the augmented bonding curve is much more sophisticated. It's much more suitable for project funding, as you'll see in a moment, actually. So, but what we'll do to enhance this workshop a bit is we'll be creating an augmented bonding curve, sort of with a goal in mind, which will be to tackle to implement a use case, sort of a health incentive bond, which will see yeah, we'll have an organizer which creates the bond, and then we'll have participants which are they're expected to do some exercise in exchange for atom. So with every day of exercise that they do, they will get one atom, and they can choose to invest it into a bond to buy fit tokens. So that's our use case, which we will implement using the bonds module, the augmented bonding curve specifically. So just a bit of context on augmented bonding curves. This is not something that we came up with. It's actually based on research by Block Science, which is amazing work, really. Yeah, and so what are the main characteristics of this augmented bonding curves? Augmented, yeah, said that correctly. Yeah, the main characteristic, if we compare to what we've seen so far, is that it has multiple sort of phases. We have the hatch phase, where we have a sort of a fixed price, and only buying is allowed. And yeah, once a certain threshold is met of tokens coming in, so reserve tokens, atom in our case, we can transition to an open phase. We'll see all of this in a bit. But yeah, then in the open phase, we'll have a sort of a normal, more normal bonding curve experience. Another thing which the augmented bonding curve also has built into it is like a funding pool. So this is very similar to the fee address that we saw earlier, right? So a part of the reserve coming in will go to a funding pool, which the main objective for that will be to fund the project, essentially, that we're having. So, but in our case, since the organizer is not really interested in like taking funds for himself, we're not setting any fees. So any tokens that the people exercising submit to the bond, all of those will be used for like the purpose of the bond. Yeah, so let's go ahead and I'll just restart my blockchain so I have a fresh slate. No unexpected behavior, and I'll clear my screen here. Yeah, so once again, so let's make sure our blockchain is running. Yep, it's running. And yeah, let's go ahead and save some addresses for use later on. We'll create 3 participants. They will all have a blank balance, right? So it will be easier for us to sort of so all of these will be an address. It's a new address. It will be easier for us to check their balance increasing, right? Yeah, and now we get to creating the bond. So the bonds module, when we're sort of creating an augmented function, we have quite a number of parameters to set. But I think it's maybe a bit more straightforward to set them, actually, rather than just speaking an m value of n and the c, like the power function. They have a bit more meaning. So we have our d naught here, which specifies the initial raise, like the amount of tokens that should be that will go through the bond process in the hatch phase. We have our p naught, the price at during the hatch phase, which will be fixed, as I said earlier. In our case, we will set it to 1. So 1 atom will be equal to 1 fit token. Theta specifies the amount of the hatch, the amount raised during the hatch phase that will go to the funding pool, and sort of like similarly the amount that will go to the actual through the actual bond. And we have kappa as well, which will specify. This is very similar to the power function, like n, the exponent, right? So it will dictate the price curve that the bond will travel along once we are in the open phase. From these 4 values, we have 3 further values that are calculated from them. The formulas for all of these can be like easily found. So we've included them in the bonds module under the spec folder, I believe. But these are like augmented bonding curve formulas, which you can find just by searching augmented bonding curves on Google. Yeah, so using those formulas, we come up with 3 further like values: R0, S0, and V0. R0 will be the reserve that will be in the bond once we go to the open phase. So what's the difference between R0 and D0 is R0 will be D0 minus the amount sent to the funding pool. So it will actually be the amount that's left in the bond once we start, once we go to the open phase. Supply S0 will be like the supply once we reach the open phase. Since the price is 1, this will match the R0, so they will be equal. So if we have 1 million atom, we will have 1 million fit tokens. And then from the R0 and the S0, we get this invariant V0, which again, the formula for it can be looked up, but essentially it's an invariant which relates the supply and reserve. So it is used in a variety of functions where when buying and selling. So we don't have to recalculate everything from scratch whenever we buy and sell. That's basically it. But it's very important. It's sort of the core of the model. Yeah. So let's actually create our bond. I'll explain any other. I mean, all of these parameters again are from here. 1, 2, 3, 4. We have the augmented function being used as the function type. The token in this case is the fit token. We have a max supply. I mean, this could have been set, for example, to prevent someone from just claiming that they did exercise repeatedly and just infinitely minting fit tokens or something like that. You can sort of specify a limit when the project is expected to end, I guess, or the incentive, right? what's the last thing that's interesting from these parameters is the outcome payment, which is a bit of an alpha bonds twist to all of this. So the outcome payment introduces to this process of hatch phase and open phase, it introduces a third phase, the settle phase, which actually this phase will only reach it if the project that our sort of augmented bonding curve represents is successful, right? So it's the outcome payment is sort of an amount promised by the organizer, or I mean someone equivalent, I guess. It's promised to the bond if the goals of the bond are reached, right? So this amount will be paid directly to the reserve by the organizer or whoever, and it will be available to the investors essentially. So if Alice has one atom and passed it to the bonds module, got some FIT tokens in return, once the outcome payment reaches the reserve, her FIT token will essentially be worth much more. So it's sort of a reward for sticking through and believing in the project. But yeah, I mean, Sean will elaborate on that, give some more context, and yeah. But essentially, I think that's it. Yeah, so let's run through a typical day of exercise, right? We've created the bond. Now we have day one. Participants 1, 2, and 3 all submit a valid claim that they've sort of done some exercise. It got evaluated somehow, which actually a side note, this claims and evaluation mechanism is actually implemented in IXO and the IXO blockchain. So the bonds module really finds a nice place in the IXO blockchain, specifically as a use case. So, but we're just focusing on the bonds module part of it, right? So yeah, let's assume that they submitted a valid claim, that they did some exercise, it was valid. So the organizer sends them one atom each. We're going to submit all of those. Our organizer is Alice. Alice is very involved in bonding curves and anything else. And we're sending to P1, P2, and P3 some tokens, right? So if we query the balance of one of the participants, they will have one atom. All of them will have one atom. Yeah, so now that they have atom, again, our bond currently is in the hatch phase. By querying the bond, we can actually see this, like it's one of the variables in the bond itself. And yeah, now that participant 1 has some atom, they can buy some FIT tokens. So they'll invest in our bond. Yeah, and I mean, given how we've set the initial raise values here, like the initial raise was set to 1 million, and we've just put in 1 million microatom here. So that one buy, this is a bit of a sort of a scaled down version, right, of a compacted version of augmented bonding curves. Just that single buy has changed the state to open, since we've satisfied the initial raise amount. So if participant 2 comes along and tries to buy FIT tokens with their one atom, they will get less FIT tokens, right? The open phase will charge them a bit more for their atom, for their FIT tokens rather. So they will get 0.26 FIT tokens, whereas participant 1 got 1 FIT token. So like the interesting thing is that since we're using Atom, since our participants are getting rewarded Atom, they can actually just choose to keep the Atom to themselves, right? Maybe they don't have, they don't think the project will be a success, and they decide to just keep the fit tokens for themselves, the Atom tokens for themselves. So that's what participant 3 is doing. He does not buy fit tokens, he just keeps the one Atom. Yeah, so our bond is now in the open phase. And these are, I guess, some fun facts. P1 and P2 are both able to sell now. Like now that the bond is in the open phase, specifically, both of them are able to sell their fit tokens. So they're not really like forced to keep their fit tokens at the moment. They can sell and rebuy their fit tokens if they wish. Another thing which we might set up is sort of a secondary market for fit tokens, where, I don't know, like maybe we can use the liquidity pool mechanism, the Uniswap-like feature that we presented earlier, to create a fit and USD pool. Maybe someone wants to buy fit tokens without actually doing exercise. Yeah, but they will have to charge a bit more. Maybe we will set the sanity rates and all that accordingly, so that they have to pay more if they don't do exercise. Yeah, so here we'll assume that some days pass, sort of the participants exercise, more item is exchanged, basically like a repetition and the mix match of what happened before, right? So we've come to the end of the project, and sort of the organizer has decided that they're going to make the outcome payment of 300 atoms. So that's specified back when we created the bond. Alice is going to make the outcome payment. So this what it will do again is send 300 atom from the balance of Alice to the curve, the bonding curve, the reserve of the bonding curve, which will be available to all those that have fit tokens. So participant 3 won't benefit from this outcome payment, but participants 1 and 2, they will. So I make the outcome payment. So if we query the bond, which will show the current reserve, it actually has 300 plus 2. So we have the 2 atom sent by participants 1 and 2 when they bought earlier on, plus the 300 atom that was sent from Alice when she made the outcome payment. Yeah, and another fact is that like we're in the settle phase now, which actually does not allow further buys and sells. We're at the end of our project. The only thing that remains is for participants 1 and 2, since they have fit tokens, they can withdraw their share. So this is essentially very similar to selling, right? But there will be no sort of any front running possibilities here. It's just they're getting a proportional share of the reserve pool, right? So the order doesn't matter. Both of P1 and P2 withdraw their share, and if we query their balance, yeah, they will have the atom back in their account, and they will have a much greater amount than what they started out with, the 1 atom, right? So P1 has 240 atom, and P2 has a bit less, since P2 had a bit less fit tokens. Yeah, and of course P3 did not trust in the project, and he still has his 1 atom, which he proudly hangs on to. But he's jealous of P1 and P2, of course. But yeah, it could have gone the other way. So what's interesting is actually to just see sort of the possibilities of this. It can, the project can fail, the project can succeed, and what we did not take into account in all this this process is what P1, P2, and P3 think of the likelihood of the project succeeding, right? Their opinion matters, and we're not taking it into consideration. So that's where alpha bonds fit in. They sort of complete this puzzle. They make the bond a bit more smarter. Yeah, and that's where I think hand it to Sean, unless he thinks I have to explain something else which I missed. Let me know, Sean.
Miguel, you've done an awesome job. So we've run through the nuts and bolts of how to configure these various bond types. And now the question is kind of what would you use this for? Why should we be doing it? So besides the utility of a Uniswap-type function, which is really just a simple utility swapping one token for another to enable interoperability and so on, really what becomes interesting with this mechanism is how this provides an interface between the real world and what happens on chain. So we have a state of the world which is represented by our kind of real world observations. And in the case that Miguel presented, and which we'll see playing out in some simulations to see how that goes on over time, Matt will present in a few minutes. In this regard, agents who are acting within a real world system, they're doing exercise or not doing exercise, and we're trying to incentivize them to take collective action towards achieving a team goal, which is really the purpose of this demo that Miguel provided. But you can imagine this in any sort of application, whether it's around delivering renewable energy or improving primary school education or whatever. And so on the one side, we have the state of the real world. And on the other side, we have a blockchain state, and we have state changes that are happening there, which are creating the incentives that would make people do things in the real world. And so just as we have an interface on our car, for instance, which enables us to take the observations about what's going on in the real world, interact with this engine, it provides an interface that then does things at the mechanical side of the system. And so we can really think about bonding curves as being this interface between the real world and the cyber world. And the interface enables state changes to happen on both sides, which are interdependent. And now, the first iterations of bonds, such as the simple bonds that Miguel showed in the first example, really don't have any information about the outside world. They just have agent behavior that is people buying and selling based on pricing. And so with alpha bonds, what we've designed is a mechanism that is able to incorporate signals from the outside world. And we call this an alpha signal, which is giving us a prediction on whether an outcome state is going to be achieved or not. So is the team going to achieve its exercise goal, which maybe is set at 80% of all of the team members doing a sufficient exercise on a daily basis for a period of 2 weeks. And we'll see how that plays out in the modeling that Matt will present shortly. And so when we configure these mechanisms to give an estimate of the real world and approximate what goes on there, and then play this out over time so that we get the bonding curve adjusting so that it forms this dynamic interface between a dynamic real world scenario and what's happening in the state of the blockchain. We really are dealing with a configuration space. And Matt is going to explain this and demonstrate it in the CAD-CAD simulation. why this is really powerful is that prices, are one part of the equation, because we have an instrument that is able to incorporate a whole lot of information about what's going on within a system. And so people choose to buy or sell based on a whole bunch of information that they have. And this collects a lot more information than we can directly collect. But when the information is also about what's going to be happening in the future, if we're able to collect information that is based on people's beliefs or other information that they have about how likely a future state is to emerge, this becomes a very powerful data point that can feed back in. And so with alpha bonds, we have got both a mechanism to do dynamic pricing using bonding curves, as well as a prediction module which incorporates user beliefs in an outcome, whether that will be achieved or not, and feeds that back in to dynamically change the bonding curve by shifting the shape of the curve. And so this is what we're going to see now as Matt shows us, based on the example that Miguel started to initialize. If you had to play that out over time in two different scenarios, one scenario where there's a success of the project, the outcome is achieved, and the other scenario being a failed scenario where the outcome is not achieved, what does that play out to do for agent incentives? And so with that, I'm going to hand over to Matt. And so Matt is from Block Science and has done a huge amount of the work on this mechanism design. So I'm going to stop sharing my screen and hand over to you, Matt. Thank you very much. Thanks so much for being on the call today.
Yeah, thanks, Sean, and thanks, Miguel, for setting the stage and doing all that work. I am going to share, and I will hopefully I'll be showing a lot of pictures, and hopefully that will help to make sense about how everything interacts. I'm the lead systems engineer at Block Science, so therefore I think about these things in those contexts. So, can I confirm that you guys can see this? Yeah, okay. So this looks okay, I hope. So to just level set a little bit about what Sean was talking about is that we have this risk prediction module. And so Miguel did a great job of explaining what's happening on the bonding curve side and how you have different options for not only developing and instantiating a bonding curve, but now we have this other piece about risk prediction and what people can do with that, but then also how that affects bonding curve. And so, so we're calling that alpha is kind of the signal that's happening within the risk prediction module that's being influenced by what people do, what agents do, and then in turn that provides an update to that kappa, which the exponent on the bonding curve module that Miguel was discussing. And so this work we've done through Interchain and with IXO as our implementation partner. And so it is on a public repo. Here we're finishing the last bits of documentation for this, but we can see that this is the implementation use case for these impact bonds using this risk prediction market, where once those participants have their tokens through the bonding curve, then they can also further provide an attestation about whether they believe the project will be successful on the positive side or fail on the negative side. And so we've done quite a bit of testing through this. So we'll go through one fairly simple version, but before we get to that, so yeah, we produce these models in CAD, which is also an open source project that we've developed. And so what we do here, so if you're, it's a Python module. So if you're Python, you can install this and run CAD, and we essentially simulate through the CAD engine what happens kind of over sets of blocks where, so for instance, one block would be kind of the earning of the reserve token. Then the next block would essentially be the bonding of it, and then the next block would be the attestation, and then that would essentially, and then resolving that, or essentially executing those. Kind of think of that as like your execution of the block, or like what we would call one time step before I moved on to the next. There's a lot more there, but you can start there. So you can install CAD through pip or through our open source repo. Okay, so then for this project, I won't go through this, but this is pretty advanced. But essentially, what we have overall is that we have a state of the system. So this kind of top row, and then essentially those blocks that I discussed earlier are essentially the different actions that can happen, and those so the actions or policies occur in the second row, and then kind of the resolution of those mechanisms, or the state, what we might call the state updates, occur in the third row, and then those update the states, and as well as any kind of like state-based metrics that we have. So keeping this in mind, hopefully that was big enough for you guys to see. Keeping this in mind, with the audience, what we did was kind of tried to translate this into Cosmos-SDK language, and I make this a touch bigger, that we have, so you have states, and we can have metrics, and then essentially the actions can be sets, either messages or queries, or like policy, like how we mentioned before that we have policies, so those would be through keepers, and then the messages themselves might be sent either through a handler or directly to some straight transition, and those would essentially update the state. So that's kind of like a rough framework of how this might map to Cosmos SDK implementation. And then, so from there, I wrote really just translating our CAD model into that framework for Cosmos SDK, but I am a Python CAD modeler, so I'm not a Cosmos SDK implementer, so developer. So you know, so that's that's the caveat on that. Okay, so then, and yeah, so what I should say, and then so what we've done is we've essentially set up these two demonstrations about success and failure. So what we're doing here is that we've set up a system similar to what Miguel described before, but now we're adding in this variation of alpha. And actually, I will, before I do that, I will just say, so what Sean was talking about is a little bit about this missing piece about, okay, what's happening on the outside world and how are people feeling about the project. And so, you know, we kind of view this as this social system or a social sensor fusion type problem where, you know, people can buy on the bonding curve, and they're going to buy tokens and sell tokens, and that gives you some idea about how they feel about the project. And then they can also do this attestation, and they can essentially make a further pledge about whether they believe it'll be successful or fail, and that will essentially give you rights to this other pool of the coins, essentially, of the tokens. And so, you know, that's our idea about how this how this is working. And so we have, like I said, many tests about this. But for this demonstration, what we can see here is, like I said, we have essentially this type of model where we essentially are turning off a few things as they're not selling. They're essentially getting those tokens, and they're bonding to the bonding curve. So we kind of see some of the same things that Miguel had essentially as the so this is essentially taking that once it's been hatched, what happens? And so in this case, for this demonstration, what happens is that we have 10 participants. So each time step, so kind of each day, they get a token, they bond on the bonding curve. But what's going to happen is that there will also be this influence from alpha, meaning that people are attesting positively or negatively about this project, and therefore that is changing alpha, which will change the bonding curve shape. So therefore it will change the price of what the next person does as a result. So if we just go, this is just all, I brought in a lot of things into this notebook that you can change. You can change it. You can go to our repo, and you can change things in the source code itself. But I brought some of the things up so you can kind of easily update them and change them. And I can, if there's time, I can show some of those things as well. But essentially what we have here is we have the 10 agents and they're attesting. And so what we're doing here, so this is kind of our driving signal about what's happening with alpha. So again, this is conditioned on success. So we're kind of saying that, well, it'll be moving in a positive direction with some noise. And so here's what's happening on the bonding curve side, is that we have reserve going up linearly because they're essentially getting each token each day. So that's expected. And then the supply I just broke out because just with the ratios, so it is curving, according to essentially the updated bonding curve. So it is not perfectly smooth as it would be in the case before with Miguel. So you can kind of see a little bit of variation here, but otherwise it would. And so that is because of this alpha influence. And so then this shows the influence of alpha on price, but also again interacting with still there are reserve essentially bonds happening on the bonding curve, so the price is still moving as a result of that. And then there's this also extra movement because of the change in alpha. So we can kind of see that. Or we have kind of our hatch price at 1, and then there's purchases, there's bonds, but then then I moved down probably because there's a little bit of noise heading down for the agents for alpha. So that would have come from agents attesting negatively to the project. And so then we look at what the agents get for their payouts at the end. And so so this is where on success they're essentially getting their tokens back, essentially converted back into the reserve currency, and then they're also getting the benefit of this outcome payment. So again, kind of that the incentive of that, if everyone does this, they'll earn this extra payment. So we can kind of see that because they would have had, over the course of 2 weeks, they would have had 14 million micro tokens here. And so if that's where they would be here, somewhere about 14. But because this payment was approximately triple, well, a little double than that, and spread across these 10 agents, you can see that they earn, this is their total payout, and we subtract out what they would have gotten if they didn't do anything, didn't participate in the bonding curve, as Miguel said before. They still had the option to not bond in the bonding curve, but then they wouldn't get a stake in that outcome payment. And so we can see even with the with alpha, so that creates a little more variation in what's happening on the bonding curve side, but you can see that they are still earning quite a bit of profit, again, because of that spread of the outcome payment across, but then also depends on what is happening on the alpha side in terms of when they enter and exactly what they'll see, what they'll actually earn. So let's see, should I jump back into the stream here to see anything? No? Okay. So if I go to the failure side, I can go through that pretty quickly. So again, so we've run a lot of tests, and so there are different ways that this could fail in terms of alpha. So in this example, I'll just jump down because the only change, if you want to run this in the notebook, the only change you actually have to make is right here. Turn it from success to failure. And so in this case, not that one, this one. So in this case, I'm driving the alpha signal down. It doesn't necessarily have to go down, right? It can just not meet a threshold, as Sean explained before. So we're going to see that this will affect everything negatively, but that, again, that doesn't have to be the case. We can kind of do like a mediocre case that would still fail, and so like that's important to realize as well. So the differences here, obviously this is the only difference, right? But then we'll see what that does. So again, so we can kind of see that there's a different, slightly like a pretty different spread here, and again, that is because there's an effect on the price because of the change in alpha, which changes kappa, which changes the price. So we can see that the spread is a lot closer because the price on the bonding curve is decreased. And so, yeah, so we can see that the supply is increasing much closer to linear here, and that's because kappa actually decreases from 3 closer to 1. So it actually becomes closer to being a linear function. And again, it doesn't have to look like this. This is driven by this alpha signal. So it could still be inverse parabolic if kappa became closer to 2 instead. And so, yeah, so again, because we're driving this down, we get kind of the price kind of shocks down, and we kind of are keeping it down there because these alphas are continually coming in at a decreasing rate, again, just for this demonstration. So the effect of that, though, on the agents are, number one, that they don't get so if the project fails, whether or not alpha was driven down hard or whether it was mediocre, they don't get access to that outcome payment. So therefore, their 14 million that they started with is roughly what they're going to get out at the end of the project. Now, because there is no excess payment, that somebody is going to have to lose in order for anyone else to gain. And because this is essentially now a zero-sum game, because there isn't the extra payment out there. So because the first agent happened to bond earliest at the highest price, therefore they actually get the lowest return, and then all the other agents kind of slightly increase accordingly because of that loss. So we can kind of see what their profits look like. So that essentially, I mean, this looks drastic, but it's not that much, honestly. Like, well, I mean, you're losing approximately two of your 14 tokens for agent 1, and then essentially they're dispersed across the other 10 agents. Let's say, so that was a lot. Are there any questions? Hopefully people are even here. And I could run this again. I could change it and run it if we wanted to see anything else.
Yeah, thanks so much, Matt. I think so for anyone watching this, there's really great documentation in the GitHub repo, and hopefully watching this presentation will inspire you to go and read the documentation, start engaging, bring your use cases, and ask questions there. This is probably some of the most kind of on the cutting edge of what you can do with bonding curves. And we're really excited about this being used for some meaningful purpose. And so when we're talking about behavior changes or driving incentives towards state changes in terms of kind of what's meaningful in changing the state of the world, whether that's a team improving their health or any of the other examples that I mentioned earlier, this is really potentially a very powerful mechanism for programming resources into sustainable finance, sustainable development, and social good. So yeah, I think that's pretty much all we have for today's demonstration. So we've taken a walk through kind of from the basics of the bonds module, very simple bonding curves, as well as a kind of convenience or utility function, the swapper function, which can also be composed into solutions. So you can create secondary markets on these bonding curves. And then we've gone all the way through to the augmented bonding curve, which includes an outcomes payment component, which is then taking the augmented bonding curves to the next level, and then demonstrating that in the context of a composable system, which has the prediction market as well. So really covering a huge amount of ground today. And thanks very much, Miguel, for all the preparation work, and to Matt and the Block Science team for the year of intense work on the research on these mechanisms. And we really hope that people will feel inspired by this, will engage with us. And yeah, we've put this out there for the Cosmos community, funded by Interchain Foundation. And we look forward to you engaging with it. Thanks very much.
Thank you. Could you please share the GitHub link in the private chat, and then I'll share it with the chat so all the viewers will have the direct link. Yeah, perfect. Thank you.
Do you want?
I mean, I think there's more than one useful GitHub links that we can share. So maybe if you have Block Science GitHub repos as well, yeah. And I mean, on the README that I sent, there's also just some further links as well, which you can just anyone can just follow and read on.
All right. Well, thank you so much, guys.
Yeah, thank you.
Thank you.
It was fun.
And yeah, thank you to Interchain and IXO as well.
All right. Bye.
Good. Bye-bye.